So let's actually have our Chimps to actually work. Now, well, it's pretty straightforward that in Sims or any other game like that, we don't actually call for a Pathfinder unless there is an action involved with it. So for example, I wouldn't just move the mouse and I will calculate a path. I will tell to X sim, go do that, go go make food or whatever, use the toilet. Okay, so that actually makes our life a lot easier because we don't have to worry about how many calls we're doing per second, which means the scheduler is also going to be even more simpler. So let's clear up some of this. We don't really need the stopwatch anymore, to be honest. We've seen that it's pretty fast, and I think for the most part in the Pathfinder we're not really going to be using a lot of different cases inside the nodes, just if they are walkable by default or not, and that will be it. So I don't think we're going to need anything else. So let's fix that these guys will randomly select a point, any node inside the level, and we will have them walk there. Okay, to do that, let's go under the grid object. And what I'm actually going to be doing, I'm going to be saving the node or the path each one has. Okay, let's zoom in a bit. Or let's just call it current path. We don't need to make it like that. So we're going to say public void load path. We're going to be handling a path. And then for now, just current path. Now, for the needs we have for this video, we can say that if you have something on the current path, so if current path dot count is greater than 0, then we will be doing the call for moving from one path to the other. Okay, so let's see, I'm going to just use handle movement. Okay, and then we're going to need a few variables. For example, we're going to need a bool if path is init, is path init. Okay, so if not is path init, we're going to be saving a few variables. We need to have the starting position, the target position. For now, well, we also need the rotation, to be honest. We can also have target rotation. And yeah, I think we could just handle it by rotation, target rotation and start rotation, if you want to be precise. So we're also going to need a move t. We're also going to need, and let me think, yeah, actual speed, or well, the speed value, yeah, no, actual speed, which is going to be internal because we're going to be calculating a few things. But you know what, maybe we should split this up from grid object to something else, but for now this will do. So I'm going to use public float movement speed. We'll set it to 2 for now, and a rotation speed. And actually, we're not going to set it to 2, we're going to set it to 1. Rotation speed will be something tiny because we're going to be subdividing. Okay, so if not path is init, we're going to be set that to true. Then the start position will be from our current node dot wall position to, we're also going to need an index. Okay, so when we're loading the path, we're also going to be clearing up the path index, and if path is init, it's going to be false. So target position is going to be current path index dot wall position. Okay, from that we can get the distance between the two, and where that is going to be useful is in the actual speed, because the actual speed will be the distance subdivided by the movement speed we have above. Then we need the start rotation, which is really whatever we already have, so that will be just transform dot rotation. Then actually we already have that. Then we need the target rotation, which is the direction between, okay, we're going to make a rotation from the direction we have from target position to start position, and all that is going to be normalized. Okay, then we can set move t to 0 and we are ready to start. So move t, we're going to be adding by time dot delta time subdivided by the actual speed, our move t, and adding that to our own position is going to return us the correct amount. Now for the rotation, we're going to create a target rotation, and we're simply going to be lerping in a spherical manner, so that will be a slurp from start rotation, start position to or move t actually, but we're going to be moving, yeah, okay. So here's what I'm going to do. This will be target rotation. Our move t, we kind of want them to have a similar value, but yeah, you know what, let's just use time dot delta time subdivide by rotation speed. But the only thing I'm going to change is I'm actually going to be passing the delta in here. Okay, so I'm going to be using only one delta inside the update, which means float delta time dot delta time and then handle movement delta. So with this we're going to be moving around, we're going to be rotating. Awesome. So I think, yeah, we also need to assign that rotation, transform dot rotation will be tr. Now let's have a callback onto our load path, and let's see, where should we create that callback? Let's just do it here, and we're going to do a public delegate void on path reach callback. Okay, then when we are loading the, well, actually for now I don't really want to pass the callback on the path reach. I'm just going to hard code it in here. However, we're going to keep the variable in here, and we're going to assign a random grid position. Okay, so on path, no, here, assign a random grid position. Okay, that will be it. And once we're here, which means we do not have any more paths to go to, we're going to say if, actually we don't have to use if, we can just use this ternary. So it means if it's not null, then invoke the delegate. Okay, so in here we're simply going to be getting a random position from the grid, and we're going to be requesting a pathfinder. On the grid manager, let's assign a random, let's just say public node get random node. I don't think we're going to have any other use for this, just for testing. Or maybe we can just make some, some neighbors getting lost or whatever. So we need a random value between 0 and the size x. So let's say x random.range and random.range between 0 and size z. For y, we're just going to use null. And then we're going to say return get node x, 0 and z. And I think I'm just going to clamp them. I don't really care if it doesn't return a value. So back to the grid object, we're going to say random node equals grid manager get random node, or singleton get random node. Okay, I'm not going to check if it's null or not. We know it's not null. And I kind of want to have a little bit of a delay for this, just so that we see that they actually reach their nodes. So for this case, let's just create a void request pathfind to node, and I'm simply going to do an invoke in here for after 2 seconds. Yeah, okay, we actually need to store the random node somewhere, so I'm just going to take this and leave it in here. Okay, so we're going to call pathfinder master singleton dot request pathfinder from my current node to the random node. Okay, and for callback, we're simply going to say, well, actually we don't have to, we don't have to pass the callback. We actually can't just pass the load path in this case, which works fine with us. Okay, so right now we just bypassed entirely the game manager. Okay, and that's what we actually want to do. So for now, I'm just going to drop this inside start. And in the game manager, I'm going to simply just comment out all of this. We don't really need them. Okay, because we are going the pathfinder from inside our objects. So technically, if we hit play now, it should have both of these guys pathfind to a random position, and it will make them walk there. And true enough, it does. Okay, it's entirely random, although I'm guessing you can see where they're going. I don't know if they're going to go on the same position, and they aren't. They just go on different positions, and then they select another position. Now, I think the start rotation is misbehaving, or at least they are going really slow. So let's make this. Let's switch this to local. Okay, 0.01, it seems to be working fine. Rotation speed, let's set this to 0.01. Okay, so that's perfect actually. As you can see, they can rotate pretty fast, and they just walk around normally. And I don't think you can notice any spikes or anything. Speed is very valid. Awesome. So let's fix the rotation speeds, and for now let's just make them move a little bit faster. And let's hit play again. They're actually walking slower. Oh yeah, they have to recalculate again for them to go faster. And he has to reach the position because we are doing, yeah, we are subdividing by speed, yeah. Let's see. What? Yeah, okay, so let's just make this faster then. Okay, now we have them assign random positions and they request at random at any time. Okay, they request positions and they request pathfinders. It works perfectly when we have two objects. Let's see how it works when you have even more and even more. I don't know if this will actually be enough for them to be taken as to actually create a problem, but let's see what this is. They are requesting the random node. Yeah, okay. Before the grid exists for some reason, or I think somebody is outside of the grid, although it doesn't seem to be the case. Let's close them for now. Let's hit play. Let's open them up. And as you can see, well, actually things start to get messy, but we don't know if it's from the debug race. So let's go under the Pathfinder and remove any debug case we have, because we don't actually need it. But it's still a lot of line counts done per frame, or yeah, especially when they're going to do all of it together. So let's hit play. As you can see, they work fine. On the first one, if we even open the profiler for this, on the first frame, you will notice there's going to be a huge, well, okay, that just collects. You notice there's a huge spike that leaves us even below 30 FPS, even though you couldn't notice anything. But if we want to just check, it took 10 milliseconds almost to go through. Physics update. I think it should show anywhere over here. But yeah, obviously the spike is because we have a lot of, actually I didn't close that, hold on. So yeah, the spike was because a lot of them request for pathfinders, and not only that, we're doing a lot of recast and so on and so on. So what could we do about that is to actually create a scheduler, if we haven't already, on the Pathfinder. Okay, we haven't. So how do we request the scheduler? Simple. We're going to, first of all, allow okay, schedules per frame. I'm just going to leave it at 1. I think at 1 should work fine for everything. And of course, depending, well, because of the way that the sims work and how they handle, you do not actually need to have responsive control over your sims. You just assign a job. Once that job, or once what they are already doing is complete, let's just go and move to the next one, or create a random, or if that's disabled, then they could just go based on needs and so on and so on. Okay, so we're going to say this as Pathfinder jobs. Okay, and instead of calling for the find path, we're going to do pathfinder jobs dot add the path call you have. So while, actually not just while, and we're going to say integer schedules or jobs done, this term, this frame, we're going to say jobs done equals 0. Then while jobs done less than the schedule per frame, jobs done plus plus, then pathfinder jobs 0 dot find path. Okay, of course, if pathfinder jobs dot count is greater than 0. Okay, so this will do the jobs. Then we need to simply say pathfinder jobs dot remove at 0. And that's it. It will do as many jobs as we set in the frame. We can just leave it at 1, to be honest. And it will remove, if you do not want to use the while loop, you could just do this without all of this. And it will only do 1 per frame. But why not just have more if we want to? But I don't think this type of game needs this. Okay, 1 pathfinder job per frame. Okay, so that means you can do at least 60 pathfinder jobs. If your game is running at 60 FPS, you can do 60 pathfinder jobs in a second. That's an enormous amount for what we need. Okay. So let's hit play, and we should see each one of these guys. They should be running one after the other. Yeah, of course. I don't know why these guys are calling the get node before we even start. But that's weird. But we can fix that if we go on the grid manager, and instead of doing this at start, we just do it inside awake. So that's easy to do. Void set, actually you need grid, or yeah, we already have that, to be honest. So do that, and then let's create this as void snap objects on grid. Now I think also for this we probably won't have a need for it, but whatever. Okay, let's hit play. We still get the error from somebody at least. Yeah, because current path it's not null. It's null. So basically there's two ways to fix this. The simplest one will be to have it already init as a list, as a container. Okay, hit play. And there we go. We have our little chimps going all over the place, and I can just keep stacking. Well, now I'm comparing all of them. Now, probably the animations, the 3D stuff, and so on, probably are going to take a lot more of a performance hit. As you can see, I can keep going. They're probably going to take a huger performance hit than the Pathfinder giving up. Okay, and you can see if there is just too many calls, it will just take a lot more time to request a Pathfinder rather than do the actual pathfinding. Okay, so I'll leave you with this, because I think that's a more organic endpoint for the video. So what we did today, we'll basically had our units, our characters, the most important thing we did today is the Pathfinder scheduler, and as you saw, it wasn't that important, but we also added our units to be able to find a random node and just go there. Okay, so that's it for this part. As always, you know what to do. Like and subscribe, and if you like to see more, if you like to, other series, other stuff, more things like this, and so on, then consider supporting me on Patreon so we can keep making all of these nice and beautiful things we're making. I'll see you next time.